Yeah guys, so I posted on the other video, so we're continuing on the summary or the synopsis of the entire thing that we have learned about bosons and the energies and all these particles in general. So we are going to tackle this thing next, gluon, what a gluon is. Now from the previous video is a continuation of the other I just post. So what is a gluon? It's a type of elementary particle that mediates the strong interaction between quarks. A strong interaction between quarks acting as the exchange particle for the interaction. Okay? And gluons are massless vector boson, thereby having a spin of 1. So you know about the spins because we talked in the other video. We have spin, integer spin, 1 integer spin. So we talked about this. I'm just reading to you the summary so that we carry on. Now I've just mentioned to you about a vector boson. So what's a vector boson? In particle physics, a vector boson is a boson whose spin equals 1. It equals 1. That means from the point it started, if it spins, it comes back to that point. Then it's a 1. But in our spin integer, it will come the opposite from where it started. Yeah, so that's the difference. Now, vector bosons that are also elementary particles are gauge bosons, the force carriers of fundamental interaction. So we understand gauge bosons are the force carriers of fundamental interactions. Some composite particles are vector bosons. For instance, n-vector meson, quark or antiquark. Okay. So I think that much I've told you, and in summary, that's what it means. So let's go to something else called quanta. So how much is one quanta? You know, before I started this thing, I told you I was going to give you some definition. Just to hold on a minute, I think I'll mix these things up. Yeah, I've said that some composite particles are either vector bosons, for instance, n-vector boson, quarks and antiquarks. I think this is something different. I just move on. These things are mixed up. So no, sorry, it's not about quanta. It's just confuse these two things. But since we are doing just a summary, you can go back to the videos and you just correct this thing. Now, vector boson looks something like this. I showed you in the previous video. We have Z and W bosons, right? And let's talk about muons. So I've told you what a gluon is. Let's talk about muon. What's a muon in physics? The muon is one of the fundamental subatomic particles, the most basic building block of the universe as described in the standard model of particle physics. Muons are similar to electrons, but they weigh more. It's 207 times as much as an electron. The muon is part of the lepton group, and leptons are a type of fundamental particle. So I'm going to tell you what a lepton is. Where is that? I think we're coming to that, so there's no need. We're just coming to that. Just take it that way, that the muon is part of the lepton group, and leptons are a type of fundamental particle. It sounds interesting with these terms. Particle. What do you understand by particle? Are you a particle? Are we particles? Yeah. How we are made of particles. What do you understand so far as I'm telling you all these things? Do they just pass from one ear to one side of the ear to the other? Do they mean nothing to you? Of course, because you are hearing them maybe for the first time. They mean everything, because this is how you are made. You are composed of these things. So, what's the difference between alpha and beta decay? I told you just now. In alpha decay, the nuclear loses 2 protons. In a beta decay, the nuclear either loses 1 proton or gains 1 proton. Both alpha and beta decay change the number of protons in an atom's nucleus, okay? And if that happens, thereby changing the atom to a different elements. So these are elements change by these beta and alpha decays, the alpha and beta decays. So let's go to something now, what I've just mentioned to you about the leptons. Yeah, how do you find these terminologies? Muons, gluons, leptons. They're all describing the state of matter in different quantities of measure. For example, now we come into leptons. What are leptons? Leptons are subatomic particles such as an electron. Muon, which I've just told you what a muon is, or a neutrino, which does not take part in strong interactions. That's it. That's what a lepton is. Now, what are they really in simple terms? I told you. Leptons are elementary particles, which means that they are not made from any smaller particles. They are elementary. There are 6 known types of leptons, 12 if you count their antiparticles. 3 of these are negatively charged particles, electrons, muons, and tau particles. The other 3 are neutrinos, which are electrically neutral particles. How do you get it? They're made of particles, and particles are energy. They have charges, they carry charges. Protons carry positive charge, electrons carry negative charge, and both give energy. This is how energy comes about, which makes everything happen, this universe and this world. So what's now we're going to verify something called tau, which I've given an extensive video about tau, what tau is, but just let me repeat it to you, because today I decided that I'll give you a summary of all these things before we move to something else. Now, what is tau? Elementary subatomic particle similar to the electron, but is 3,477 times heavier than an electron. That's what tau is. You see, it's the same thing, but weighing heavy. Like the electron and muon, the tau is an electrically charged member of the electron family of subatomic particles. The tau is negatively charged, while its antiparticle is positively charged. Of course, if it's negatively charged, then its opposite will be positively charged. So there's antiparticle, anti-tau. Antiparticle of tau is positively charged. Now, what is the charge of a tau? Tau have a charge of -1 and can be written as, of course, T1. You can do T is written like a T with a minus at the top. Since antimatter has the opposite of charge of regular matter, anti-tauans have a charge of +1 naturally. If it carries -1, then its antiparticle will be +1 and can be written as tau positive. towns themselves are unstable and decay so fast. You can understand because they are weighing heavy, so they are not stable and they decay so fast. So what's the mass of a tau particle? Its mass is 1777 mega electron MeV. Now there is a third heavier type of charged lepton called tau. So this is what they are called. This is actually a lepton. It's in the lepton family. The tau with a mass of 1777 MeV is even heavier than the proton and has a very short lifetime of about 10 raised to the minus 13 seconds. How fast does a second tick? And now we are talking 10 minus 1, 13. 10 raised to the minus 13 over a second. That's the lifetime of this thing. Like the electron and the muon, the tau has its associated neutrino. I'm just trying to see how much of the video is going. Now, what's the composition of a tau? Tau is defined as an intrinsically disordered protein, IDP, and is present as 6 isoforms in human brain, ranging from 352 to 441 amino acids residues. So it's interesting that in your brain we have tau there. When we are talking of these things, we are not talking of fantasies. Actually, we are talking of things which actually exist. Now, can you imagine that inside your brain, what you are having there is tau particles, which creates amino acids residues. So, this is how important tau is to your brains, because they are made from tau. What is electromagnetic radiation? Now we're moving out of tau to electromagnetic, which is one of the strong 4 forces. Electromagnetic radiation in simple terms. You're defining terms here. Now, when I talk of electromagnetic radiation, what do you understand? Electromagnetic radiation is a form of energy that propagates as both electrical and magnetic waves traveling in packets of energy called protons. Guys, I'm not going to spend a lot of time giving, because these things are already covered. I'm just giving you a summary, so I'm just going through quickly. So that is it, and if you want to know more about electromagnetism and radiation, just watch the previous videos. You'll be highlighted more about this. Now, what's a quantum electron? Quantum. What does quantum describe? When you say quantum mechanics, quantum, what does it describe? Quantum describes the amount of energy required to move an electron from one level to another. Quantum electron to another. So how much is one quanta? There's quantum and quanta. Now, a quanta, they are both mean the same thing, one being a singular, another one a plural. Quanta is a plural, I think, and quantum singular. A quantum is the minimum quantity of energy that can be lost or gained by an atom. The value of Planck's constant is given by h 6.626 times 10 raised to the minus 34 use s. What is called quanta? Now, this is what I was telling you, quantum and quanta. Quanta is plural, quantum is singular. Now, quantum is the smallest discrete unit of a phenomenon. Guys, so if you follow this thing, I'm giving you the basics actually. Even if you're a layman who knows nothing about physics or particle physics, you will be able to understand. Because I'm defining to you what is quantum. When I'm saying quantum mechanics is the motion of subatomic particles. And quantum is a unit of, is a small discrete, means small unit of a phenomenon. You know what's a phenomenon if you know English? For example, a quantum of light. What is a quantum of light? It's a photon. By the way, you know, how does matter get created? you bring the photon with a quantum of light, together you clash them in a laboratory, actually you can create matter. They form matter. An electron is formed and an antineutrino is formed. Okay, let's go on. For example, quantum light is a photon and a quantum electricity is what? Can you guess? What's a quantum of electricity? If you are following me now, you know what that is. What makes electricity? Electricity is a flow of what? Electrons. So what's the quantum of electricity? Is an electron. Yeah, man. Now let's move to the LEDs, right? I think I'm going fairly fast to summarize this. So what's an LED? An LED is basically a miniature molecular light engine that runs on electrons. The color of light produced when current passes through an LED corresponds to the energy of the photons, which is determined by the band gap of the semiconductor material used in its construction. LEDs are made. So now I've talked about the LEDs to you and the electromagnetism. I've told you about the towers, alpha, beta decay, vector bosons. I've told you everything. So yeah, man, so we're gonna stop it here. I don't know whether there's anything we should learn about hadrons or bosons or particles for that matter, and energy. Maybe now we'll delve deep into fields. And when we say, now let me sum it up, actually it's very interesting. When you say, now we go to the fields. What are the fields? Fields are, according to Faraday, is a continuous form of, it's a wave that continues, which has now to be broken by this Higgs boson through weak interactions, weak force. But now we're going to tackle fields in detail and find out what fields are. As we said, that if you want to take everything out, what remains is the fields. You take everything, atoms, these particles and everything, and try to create a vacuum of nothing. Still fields remain there. So the universe is full of electrons. But we are not going there today, so we're ending this video here. Please stay tuned, like, comment, share, and subscribe to my channel. See you in the next one. I'm not commanding you to subscribe. If you are enjoying this material, please subscribe. Okay, keep the channel going. Bye.